So for 5b, we've been told still it's horizontal. So horizontal must tell you that the direction, you can see the direction of the 6 meters per second. It's not at an angle, it's horizontal. So already it must tell you that the sign, the angle is 0. Okay, that is the concept which you must understand. All right. So this is the speed of the fish as it was drawn, as it was dropped from the eagle. So the eagle is continuing moving to the right hand side at 6 meters per second. And initially here, we are now talking of the speed of the fish, which is v. All right. So now we want to find what is the time when the speed had doubled, and what is the time again when the speed of this fish had doubled again. So double of double, you get 4v, which means 2 times 2 of the speed of the fish. Okay, so initially, before we had this 4, which is there, we just cover it for now. So it will be v is equals to square root of xi squared plus v y in the y component and x component initially squared. So before, if we remove the 4 there, we saw that this component was 0. Why? Because the sign of 0 of the angle here, the component of the y was 0. That is why vx was equals to vxi before we had the 4. So we concluded that at any time v, which is the speed of the fish, is equal to the vxi. What is the vxi? That is the component, which was the component when we calculated. It was still 6 meters per second. All right. So whenever you see vxi, you are going to substitute it by 6 meters per second. All right. But in this time, we want to calculate now, since we have already calculated the time when the speed had doubled, we found it was 1.1 seconds. So now we want to find out what will be the time, when the speed had doubled again from 2v to 4v. Okay, so what you just do, you come and say where the speed, remember the speed is represented by v, okay, without the 4. So when the speed v is become 4v, so you come and put the 4v here. Okay, so initially there is only a v, and then now we want to know the speed when it becomes 4v, just like what we did before. Initially there was just a v. You want to find the speed when it becomes 2v, you put a 2v. So this time we are going to put 4v. But we know the relationship of v and vxi is that they are the same. So where there is 4v, you substitute with vxi. 4vxi is equals to square root of that. Since we are here, all right, anywhere else, we are no longer using this relationship. Okay, we know that the velocity is equals to acceleration times time. So remember, the final velocity in the y is different from the initial velocity in the y. The final velocity in the y, there, it's no longer 0 like the initial, whereby the v sine 0 was 0. So for now, the final velocity in the y is a certain value which is dependent on time. Okay, that's why we write a multiplied by t squared, because final velocity in the y is dependent on time. So we plug in it there, we replace this by that. So we are no longer going to put 0 this time. We are going to replace it with a acceleration in the y, which is 9.8 meters per second squared, multiplied by the time, which we are looking for at this point. Then you square it. So squaring both sides, left hand side and right hand side, you square this side, then you get rid of the square root on this step. So 4 squared, this squared, the root we square, and then everything comes, the root comes out. Then we'll be left with 4xi, and then remember acceleration is 9.8, you square it. T is t squared, you square it. So 16, 4 squared. Vxi, that's there. You push this to the left, then you subtract it. Is equal to the right hand side is still the same. So we want to make t subject of the formula. How do we do it? It's the square root of. So t by square root of the both sides, then it will be square root of. We know 16 minus 1 is 15. Then you're dividing both sides by 9,8 to get rid of, you just want to be t to be explicit there. Okay, and then it will be square root of 15. Square root of vx squared, you just know it's vxi, and then we know what is our vxi, 6 meters per second. And then what is the acceleration? 9,8. Then you get the time. So the time here is when the speed had doubled, it was now 2,37 seconds. So we just want to know the additional time it doubled from here to there. You just do the subtraction. So it will be 2,37 minus 1,1, which is it. Then you can see what was the time it took to double from 2v to 4v. The speed is v of the fish.